Hello. In this video, we are going to talk about how to implement custom state preservation and restoration in an iOS application. And we're also going to talk about how it was implemented in a workout tracker application. So I have a workout tracker app, and I implemented this a few months ago to make sure my users don't lose their workout if their state is gone. But what do I mean by state? Like, why do we need this in the first place? So imagine you have like an application running, and then you switch back to another app, then you come back to the original application and you kind of see it's kind of restarting, right? Because maybe it was terminated in the background because iOS system needed some resources for the application on the foreground. So this is happening very often, actually. It's very common in the iOS apps, but not every application needs a state restoration. For some applications, it's okay if just restarts and it just restarts from the beginning. But for apps like workout trackers, it is very important to preserve the state so their experience is not interrupted. So I can show you with an example. So here I have the workout tracker app open. So imagine the user starts a workout, and then within the workout selects an exercise and starts working out. And as they complete their sets, they update the values and complete the sets. So now they're resting. And while they're resting, maybe they will put the app in the background and then go check their social media applications, maybe check some reels on Instagram or talk to their friends on WhatsApp or messages and so on. And when they come back to the application, imagine the system restarted it, which is equivalent of doing this. So when we just kill the application, it's also the same. And then when they open it again, they lost their session. So which can be very annoying and frustrating for them because now they have no idea where they were, how many minutes they already worked out, and even if they want to construct it again, they have to start from scratch and manually input everything again. So it's very frustrating. And when that happens, probably your user is going to stop using your application. So now that's why this state preservation and restoration is very important. And now I'm just going to run the app again after uncommenting something here to show you how it's going to work with the state preservation and restoration. So I run the app again. Now let's start the workout again, and then let's start an exercise. And let's say we do some changes. The first set was complete, second set was also complete, and then we kill the app. Then when we open it again, now as you can see, the workout is presented, then the exercise is also presented, and we have the first two sets completed with the correct data. So that's the idea. That's why we need the state preservation. And now we are going to talk about how it is implemented, for in general, how it can be implemented, and also how it's implemented for this application. So the technique I'm using here is kind of simple, right? So what I'm doing is I'm describing the state as a codable model. And then at certain moments, like for example, when a new exercise starts or when the data changes over here, what I'm doing is I'm updating that model and encoding it as data and saving it to the file system. And let's take a look at like how I'm doing it. So training session state preserver is the entity we're going to take a look at for this. So it has some methods like the update session, discard session, and setting active exercise for cache day, which we can talk about it a bit later, or removing active exercise and so on. And also you can retrieve the cache session from this entity, so when the app starts, you can reconstruct your previous state. So what is it like? Like update session, which is just takes one parameter, which is state preserve training session wrapper. So let's take a look at this model. So this model, as I mentioned earlier, describes the current state of the application. So it gives us the cache date, so when the workout was started, and also the session. So if you go to the session, it's an enum with some associated values. We can ignore the single exercise and we can focus on day. Day is actually like workout. Like workouts kind of called day in the code here. But so if you can go to this state preserved day, we can see that it has a day identifier, some other information, some other property like related to some training plan information. It has an optional active exercise wrapper, which describes the current active exercise if there is one, because there is not always an exercise. Like, for example, we can also cache with this state, and in this state, the workout is running, but there is no active exercise. And then all the available exercises are also described here as an array. And if we jump there, we see some planned and additional. Don't worry about it. Let's focus on the planned exercise. In here, we have two states. An exercise can either be incomplete, so like this in the beginning, or they can be complete. And if they are complete, we need to cache different information. And if they are incomplete, we need to just cache their identifier. So I won't go into too much details of like what I am caching to make it not overcomplicated. So some things I will be skipping in this video. Okay, so that's how we describe our state for preserving it. But if you go back now to the training session state preserver here, so now okay, we have the model, but we need to write it in the file system. So the way I'm doing it is just I'm going to show you soon that we are going to take this model and we're going to convert it to a data, because this is, as we just seen, it's a codable model, so we can encode it and then we just write it to the file system. So we have this JSON file writer. It's a simple enum I'm just going to show you soon. It has a write method that takes a value that's type of encodable and the URL, like where you want to save this. So let's talk about the URL. I have this URL coming from a provider over here. So if I jump here, as you can see, it's just an enum with a static property that gives me the URL, which is actually the name of the JSON file. So this is training session state preservation.json. And we are gonna, of course, append this file name to an actual URL where our app can have access to. And what we get, where we can get it, is from this another enum here, this document directory, which has a static property is the URL, which gives me the actual document directory of the application. So we call FileManager default URLs for the document directory in user domain mask and give me the first URL you found. And then once we have access to that path, that URL, we are just appending this file name to make sure we are going to be writing and reading values from this file. And that's it. So once we have the URL, now we can call write method on the JSON file writer, and we already provided the value, which is type of encodable. So what this does is it just makes sure we have a valid URL, otherwise it does nothing, and then tries to encode this encodable as a data, and then if that's successful, calls write method on that data to the given URL. If anytime any error happens, it just does nothing, which is not ideal. Maybe you want to log these and keep track of these errors, or try something else when an error happens. So yeah, it's something to keep in mind. So maybe provide better error handling than I did here. Okay, so this is how we update the session, and also how we can discard the session is we are basically writing nil as the value to the same URL. So when we did that, we are basically removing the data available in that given path. And how do we read the value? There is another another entity I have, which is JSON file reader, that you tell it's like the kind of model you want to read from the given URL, which is the session model that describes our current session. So what it does is, in this read from file method, make sure the URL is valid. If so, it tries to get the data by calling the data contents of URL initializer. And if it can acquire the data, it uses a JSON decoder to decode that data as the given type. And if everything is fine, we are going to have our session provided to us. Otherwise, we're going to get nil, which is also going to be the case when there is no active session. Cool. So this is the main entity that we interact with that helps us to update our current state, so we can preserve and restore it. So every time a workout starts, like if I start a workout, now I update the cache, the state cache, and then if I select an exercise, now I also have to update it. So anytime a property changes, I am also updating the current state of the application by reading the currently saved cache file, the JSON file, making the changes needed, and saving it again. So I'm going to go through with this to show you how I'm doing it. And after that, I'm going to show you how the application can actually read this value and then construct the presentation to make sure the user's experience is uninterrupted. So I can show you for the workout overview first. So this is the log day view. So we can go to log day view model. By the way, this project uses MVVMC with SwiftUI. So the views are built in SwiftUI. There is a view model and there is a coordinator, and coordinator interacts with navigation controllers to present or push new views. So every SwiftUI view is embedded in a UI hosting controller. Okay, so whenever the day view, the workout view is initialized, it immediately updates the cache. So in the initializer, we are already interacting with the training session state preserver. There are some different cases. We don't need to worry about them now. But what we do is, okay, now this view model is initialized. We can already update the session. We can provide the start date, the session's type of day, and with the relevant information provided over here. And then we also inject the exercises. By the way, I know the file formatting, the way I format code is not the ideal. It's a bit hard to read. So sorry about that. So if I jump to this exercise method, it has exercises available when it's first constructed, and then it goes through each exercise. So there are different types of exercise, and there are different states, like if it's incomplete or if it's complete. So depending on what the state is, it goes through each one of them and switches on different enums, and then ultimately it just returns an exercise. Like it returns a planned exercise that is complete with relevant information, or if it's incomplete, it also returns planned exercise as an incomplete exercise. So yeah, don't need to worry about too much in details. That's how we initially cache the workout state. And then when we select a new exercise, now this is another view, of course. There are different exercise types, but this one is an exercise for logging an exercise with weights. So here we have log weight exercise view model, and this guy also has access to training session state preserver, and it also makes updates on it, right? For example, first when it is first initialized, it sets itself as the active exercise for cache day. I briefly mentioned this when I was walking us through the training session state preserver. So let's go back to it. So what it does is, first it needs to read the currently available um, state information from the file system. So whenever you want to set the active exercise, first we need to have access to the current state. That's why we interact with the JSON file reader and read the current file and get the data as our expected model. If all is working fine, we proceed. So this is something we can just skip. Some checks are happening. Then what we do is, okay, we have now accessed the model. Now we're going to update the active exercise wrapper, which is the current given exercise with its ID, with its start date, its type, and the index, like the which exercise at the index of the exercises of the workout. So with all that information, we are updating the codable model. And then once we are done with updating, we are calling the update session method of this preserver again with the updated session model. So that's how we are always making changes to the current state. So every time something is happening, we are reading the current states, making some changes, and writing it again to the given URL. Okay, so now if you go back, okay, when it's initialized, it's updating the current state. It also provides the sets. So as you can see, each exercise has sets of values, the repetitions, weight, if they are complete, and so on. So the exercises have already the sets available to it. It just maps them through, and for each set, it provides a new model type of, the set information over here that is used inside the preserved state model. Cool. So that's how it initially sets it up. And then whenever a change is happening, for example, whenever the user increments the weight or repetitions, or if they save the set as complete, we also need to update the state. So then, if the app is killed in the background or something happens, it can be constructed with the correct data. I also have a method for that. So I'm not going to go through the listeners of this. Like whenever this button is pressed, this subview of this set view lets this view model know somehow. So I'm not going to go through those details. They are kind of out of scope. But when that happens, what we need to do is we need to update the state. So here I have an approach with the task to not update it very often, right? So what I have here is the set change state preserving task, which is a type of task of void and never. And then whenever something changes, first I call cancel on this task. Because if there was a previous task pending to be executed, it's fine to cancel because I'm going to overwrite everything with the latest values anyways, right? That's why I call cancel on it. And then I set it to a new task immediately after. So when the task starts, first of all, I wait 5 seconds. So this allows me not to update the values immediately. Because if a user just presses a couple of times, they're going to press maybe in 5 seconds, like within 5 seconds, press a little bit, maybe complete it. All these operations, I don't want to update the cache, you know, right away, because reading the file from the file system, updating, and saving it again has some cost associated. That's why I have this task that sleep here, that I sleep for 5 seconds. Only after that I call the update session method on the state preserver. So this is to save some resources potentially. This can also be negligible depending on your use case. So this is something you need to think about. And you can also use some Xcode profilers to see what's going on. But yeah, in order to save some resources, I add this delay. So I kind of save all these changes in batches. But of course, there is a downside to it, because if you update it, the user updates it, and within 5 seconds something happens, then those changes will be lost. So maybe 5 seconds is too much. You can try with 1 second and so on. And yeah, you can also do it without any delay, but then yeah, you're not really mindful in terms of resources. Okay, so as I've shown you now, this is how the state updates. Every time a change happens, we provide the latest set information by calling this method every time. So we get each set with the updated values. And then, of course, when the exercise is saved, we also update the workout flow. Now it's shown as saved and so on. So if you run the application again, you will see that the workout is still going on with the exercise completed and so on. So this is like how the whole state is updated. So every time something is changing, we are updating our state model. Cool. But how are we restoring it, right? How are we constructing the whole view? Again, like how we first present the first workout view, and then if needed, present the exercise view. So now we're going to go through that. So this is happening. This is the responsibility of the home view, which is here. So this view, when first launches, checks the cache, checks the file manager to see if there is a cache session. If there is one, then it will proceed presenting it. So let's go through that. And this is called log training view model. So the log training is actually the home module. And here when we first initialize, when the view appears for the first time, we talk to the state preserver and we ask, hey, if you have a cache session. If there is a cache session, we are going to restore that. Otherwise, we don't have to do anything. Okay, so we know we got a cache session over here. Then we call restore cache training session if needed. So when this is called, it checks the state of the session, like if it's a single exercise or if it's part of a workout. Let's focus on the workout, which is the day. What it does is, first of all, it gets the actual workout template from the database. So we need to have the workout template from the database, which is used, which is the core data model, a core data entity over here. And then we also need to populate the restored exercises. So if they're like the exercises of today, if they are incomplete or complete. So we run through each exercise and we check their type. And then if it's a complete exercise, we get the actual execution from the database and so on. So all that logic here, just checking for different exercise types, I will skip. And then once we populate our exercises, we also check if there's an active exercise model. If there is one, we associate it as well with our log day restore state active exercise model, which also kind of like describes it simply for the UI model, the view model later on. And then we do all these configurations, and ultimately we check if there's an active exercise. If there is an active exercise, we need to, after navigating to the workout, we navigate one more time to the exercise. Okay, so once we have all this information, we call this closure on navigating to cache day, which is called on the coordinator. So when the view model is initialized, this coordinator injects this closure, and whenever this closure is called, we get all the information, and then we say present cache day view. So we come over here, and then we talk to the coordinator of the workout, the log day coordinator, so which is the coordinator that is responsible to provide this view over here. And then we get the view with all the data injected to it, and then we say, okay, present, right? We presented this. But we may also need to present one more time. We may also need to present the exercise view, because if there was an active exercise, right? If that's the case, after we call the present method on our navigation controller, we get a completion handler. Like, okay, now you presented it, you can proceed. And then once the presentation is complete, we are telling the coordinator of the workout view, proceed with the exercise presentation if needed. Because we can't just immediately call that right after the day view or the day coordinator is initialized. Because until a presentation finishes, if you call another present method on a view controller, that will not work. So that's a bug, right? That wouldn't work out. That's why we need to work with the completion handler of the present method, and only then call the present on the other coordinator, so that it can, depending on what kind of exercise it needs to present. So I will not go into so much detail over here. It will just present it by talking to associated coordinator with the relevant information, and then it just presents it. So there's some additional logic also, of course, like to make sure we are presenting the correct exercise and so on. But I think it's going to be too much detail that's without so much value. So I won't go so much into detail. But yeah, that's it. That's how I'm doing it for a workout tracker application. So there are some parts that's kind of complex because of all the data types, data information like duration that needs to be cached. But essentially, it's simple. It's just about creating a model that can describe our state and caching it in the file system, reading it from the file system when the app launches again, and then making sure the presentations happen one after another, which can be the challenging part, because if you need to present, let's say, 4 or 5 screens, then you have to have the logic in a chain, like, okay, you present the first today, and then once that finish, you present the exercise, maybe then when that finishes, you present something else, and so on. So this can get complicated, but essentially this is the way it needs to be implemented. It's like you need some sort of a way to define the ultimate point that you want to go to. And with your current architecture, you need to wait to implement this. This could also work fine, I think, if it was a CSUI native navigation approach. You could also, depending on your state, you could understand where you need to go and then append them into a navigation path one after another, and then some sort of presentation that would also work fine. Although the presentation with SwiftWire is still not the best, but it could still be possible somehow. So yeah, that's how I'm doing it for my workout tracker application, and it really helps with the user experience. So this is very important for certain applications. So yeah, what do you think about it? What do you think about the approach? If you think it could be simplified, or if you are curious about some things I didn't explore, just let me know in the comments. We can discuss further. And also, let me know if you also try to implement it for your own applications, so we can have the discussion going. Yeah, that's all actually. And I hope you enjoyed this video, and I will see you next time.